Hi all, thanks for joining today. My name is Nicole Mysick and I head up Decision Science and Solutions at Nextmv. So I wanted to give you all a quick orientation of the Nextmv platform, and then I'm actually going to jump into an ML plus OR workflow via the Jupyter Notebook experience at Nextmv to show you all how you can set up that workflow and those child applications all within the Nextmv platform. And then lastly, we'll take a step back and talk about model standardization and collaboration more generally in the optimization ecosystem. So I want to start by talking about the state of the optimization world. And I specifically am not going to talk about the state of the art, but really the state of the world in which we live in and which we're working on optimization projects in. So typically what we're seeing in the optimization community is that it's really hard to get out of research mode. Things just sort of never transition to operational mode or production mode because of various factors. For example, launching requires precious engineering resources in many situations, right? So you have decision modelers that are doing some really amazing things with the optimization tech, but then taking that and putting that in a production environment is not straightforward and requires some time from engineering. It's also hard to test and keep track of your run history, your inputs that were run to produce a particular solution, what configuration was used. So reproducibility in the testing sense can be really challenging. And for this reason, business stakeholders can often lose confidence in these black box models since they don't have the ability to maybe be able to experiment themselves with some of these solutions and be able to build confidence in the approach that the decision modeler is putting forward. And then lastly, managing configuration can be an engineering time suck. If you have to file a support ticket with engineering every time you want to change the coefficient in your objective function, then it's just really not sustainable. So we like to think about three key players in the optimization community. First, we have our ops researchers or our decision scientists. So most people that are probably watching this recording or at Informs in the room with us. So these are the personas that build, iterate, and scale decision models. We also have the software developer persona, which is your typical software engineer. This persona is responsible for integrating those decision models and monitoring those decision models as services. And then our last persona is, I don't want to call this one non-technical users because often they are technical, but maybe less in the weeds of the actual optimization model itself and a bit higher level in terms of just interacting with the output of that model, doing some downstream analytics, running experiments, and so on. And so given that we have these three personas who are interacting with the model in some way, shape, or form, we have to ask ourselves the question of kind of how do we bring everybody together to cross that giant chasm from research and development into a production environment? And really the answer here is that everyone has to feel like there's some aspect of collaboration that's happening, and everybody has to have trust that what's moving from development to production is acceptable. So what is required here to cross that chasm and build that trust? There are a few things. So being able to move quickly, being able to scale to more use cases, managing your rollout risk, so like being able to roll back if there's an issue in production, and also as part of that, being able to leverage turnkey infrastructure, not kind of building out bespoke solutions every time. Also being able to quickly innovate, iterate, and test, and this really applies to all the personas involved. Engaging with models consistently, managing your team resources better. So being able to say, oh, we have some new person that wants to join this project, not having to catch them up to speed because the optimization models should be all standardized. And everybody who has worked in this space should understand this is how we set up an optimization model or a decision model, and it all looks and feels the same. And then lastly, managing stakeholders better. So giving them the confidence and the ability to experiment and explore the model output themselves. So we believe that DecisionOps gets you there and gets you across that chasm and addresses all of these problems. And so what is DecisionOps? It's a set of practices, tools, and infrastructure that help you take those models from a development environment into a production environment. And so specifically, this involves collaboration between those three personas, the engineer, the modeler, and the operator, being able to do model testing, both historical and real-time on production traffic testing, CI/CD for versioning your underlying model executable that's being run. Observability. So this is something that seems really simple, like just having a log of your past runs and being able to go click into them and rerun them. It's a really simple concept, but we've seen a lot of companies that don't have this. And a common API layer. So every optimization model that you're building should look and feel the same, have a similar microservice architecture that easily integrates with your other downstream services. And then lastly, that deployment infrastructure. So we know with decision models, there's kind of two types. One is sort of for your real-time operations, like, for example, real-time meal delivery routing. And then others are more like batch kind of optimizations, like you're planning for nightly scheduling or weekly scheduling of your workforce. So at Nextmv, we have built a DecisionOps platform for all of your optimization work. And so the way you can hook into this platform is typically you might have a GitHub repository and you might have a pricing model or a routing model in there that's Git managed. So in order to hook up to our infrastructure, you can push that model into the Nextmv platform, and then you get access to all of this functionality. So you get a common standard API for all of your optimization models that you hook up. You get access to the modeling SDK, which gives you the ability to expose custom statistics, expose configuration for experimentation, be able to expose logs for your software engineers, for example, and various other aspects of kind of interacting with that application. You also get access to the web UI. So this is the hub where all of these different personas come together and interact with that model in some way, shape, or form. So your decision engineers might go there to look at logs. Your decision modelers might go there to upgrade versions and run experiments. And your operators might go there to also run experiments or play around with making runs and changing configuration. And so the last piece here is the notebook experience. So we know that a lot of decision modelers feel most comfortable in a notebook. And so we wanted to bring that experience to the platform as well. So now you can use notebooks for prototyping, as well as being able to prototype, of course, in the standard ways with Git managed repositories. But you can still prototype, and then you can take that prototype and actually just deploy it from your notebook into the Nextmv console. And so that's kind of the Nextmv platform at a high level. And we have various roles that can interact with that platform. So you have your admin who might be responsible for, setting role-based access for all of the other roles. You have your developer that's doing a lot of the optimization modeling. You have your analyst who might be doing kind of more experiments and looking at run history. And then you have your viewer who is sort of that end stakeholder. Nextmv integrates with all of your existing tools. So if you do not see a tool, a solver, a modeling paradigm on this page, it's just because we couldn't fit it on the page. But we support pretty much anything on the platform that you could envision using in this ecosystem. And so at Nextmv, we know that optimization and decision models are typically just a small piece of what's going on in the ecosystem. So Maybe you have a pricing model that you've built out using Gurobipy. Well, typically that's part of a broader workflow, which is fetching the data, sending that to the optimization, and then visualizing the results. Or maybe you're linking and transforming different optimization and forecasting models together to run forecasting, then scheduling, then routing. Or maybe you're taking one big data set, fetching that from your database, partitioning it into smaller data sets and solving some problem on those smaller subsets, aggregating those results, and then visualizing those. So these are examples of different kinds of workflows that we typically see in the optimization space. And with each of these workflows, typically there's a human involved at each kind of transition point. And if there's not a human, then it might be some complex service that is recreated for each use case that you're building out. At Nextmv, we have a concept called Nextmv workflows, which allows you to actually conduct all of these workflows through our Nextmv SDK, chain them together, and that gives you the ability to really just manage each of these steps independently as well as the workflow as its own entity. And you can press play on that workflow and it will run all of these steps on your behalf. And so now we're going to transition over into the next part of the workshop, which is the ML and OR workflow. So really what we want to do here is take kind of that end state of building out a workflow and show you how we get there on the Nextmv platform. So we're going to frame this in the context of the farm share company. So the farm share company is a fictional company that is a consumer delivery service for farm-based goods. And so what we want to do here is we want to optimize avocado prices and the allocated amounts of avocados in millions that we ship to each region. And we want to solve this optimization based on how prices impact the demand for those avocados. So obviously, if we increase the price of an avocado, then the demand would decrease for that. And we also are interested in exploring the scenario of adding a new avocado supplier to the mix. So management has found some new avocado supplier and they're telling us we need to go with this supplier. So what we want to know is how does increasing the supply or the inventory of avocados that we're starting with impact our downstream KPIs like waste, profit, etc. So what we're going to do today is we're going to start from a world or an account where we have nothing, no apps, nothing. And then we're going to move to an account where we have these 3 apps deployed. We have an avocado ML regressor, which characterizes the relationship between price and demand of avocados. We have an avocado price optimizer, which optimizes for the price and supply of avocados per region. And then we have a workflow, which chains these 2 applications together with some transformations in between. And so what we're ultimately going to do here is we're going to prepare our data with pandas. We're going to run our regressor application. We'll join the results with some input data. We'll run our optimizer, and then we'll visualize those results with Plotly. And as part of this, we'll also be able to use the Nextmv platform for experimentation to see what happens when we increase our starting supply or starting inventory of avocados by various amounts, so 20 million, 30 million, 45 million. So as part of this workshop, we will be working off of a notebook for various reasons. Notebooks are really helpful for prototyping, as most of us know. And also there are many, many notebooks published out there. For example, Gurobipy has a wonderful supply of notebooks that solve interesting problems. And that's what we're starting with today is actually the Gurobipy price optimization notebook that they have published on their website. So that's really nice because we can kind of just pick that off the shelf and then extend that to show how we can take that notebook experience and bring it into the Nextmv platform. So the two kind of flows for getting started on Nextmv are either you have your own model code, and that can be local or Git managed or a notebook, or the other path is you don't have any model code and you want a starting point. So if you do have model code, like I said, you might be working off of a notebook. And in order to bring that to Nextmv, you'll just add in the Nextmv SDK and Nextmovify those models in there. If you're working off of a Git managed or local Python structure, you can use our Python SDK. Or if you're not in Python, you can use the Nextmv CLI to bring that code and that executable into the Nextmv environment. And then if you don't have any model code, then you can check out the Nextmv marketplace where we have a bunch of low-code customizable solutions to common optimization problems. And really, whichever path you take, the end result is the same in that you get this experience of having a managed application in the Nextmv console where you can run experiments, do version control, and so on. And really, an application in the Nextmv context is a UI plus an API for managing, interacting with your underlying decision science model. And so there are various ways to interact with models or apps on the Nextmv platform. So each of these different paths is actually just doing the same thing. It's making a run of your model or your application. So at the top here, we have a REST API. So this is one way that you can make a run. It's by posting to that API. This is typically used by software engineers when they're integrating with downstream services or upstream services. We also have the Nextmv CLI. So this is really common with engineers, but also there are some modelers that just prefer to use a CLI. For all the Python people, we have a Python SDK, and this is typically what we see decision scientists gravitating towards. And then, as we've already talked about, we have the notebook experience, which is just that same Python SDK, but from a notebook. And then lastly, we have our web UI, which is really for anyone, but it is especially for operators and analysts who will be preferring to use the console and that UI to fire off runs and so on. All right, so now we're going to jump into the notebook so that we can do a quick speed run of how to get to that end workflow. So I am going to go ahead and run this entire notebook. And so this is going to be running in the background while I'm going through each of these steps, but I just wanted to fire it off since depending on network connection, it can take some time to get through. So I do want to highlight one thing before we get started is when you're working with a notebook, you will need to hook up your Nextmv API key to that notebook. And so to do that, you can click on Add New Secret. You can, for the name, you can include Nextmv API key. And for the value, you can paste in your value from your API key from the Nextmv console. And so to get that API key, you can go into the Nextmv console, settings, API keys, and you can copy that value and paste it in here. And then you'll just want to make sure that you toggle for the notebook to have access to that secret. So I already have mine created, so I'm not going to recreate it. All right, so we have this notebook running. So now let's talk about what's going on in here. So as I mentioned before, we started from the avocado price optimization notebook that Gurobipy published on their website. And so really what we've done is we've taken the code that's in this notebook and we've copied and pasted it over. And we've added just a few lines of code to Nextmovify it to basically hook it up to the Nextmv platform so that we can have each of those applications versioned separately and running in a workflow. So even though this notebook seems like it's long, it's really just a lot of copy-pasted code from Gurobipy's original notebook. So for the first part, we're going to be deploying that ML regressor model to Nextmv. This, again, is a model that characterizes the relationship between price and demand of avocados. So we start by pip installing all our required packages. Notice that we're adding here to what Gurobipy was using in their original notebook 2 additional packages. One is the Nextmv SDK, and the other is a Nextmv Gurobipy package. So the Gurobipy package is really helpful because it provides some nice connectors for working with Gurobipy models. So here we're just importing all those required packages as well. And now what we've done is we've just copied and pasted the data processing code that Gurobipy used from their original notebook. So you can see that they were loading in that loading in the data frame from Kaggle and Hab data, and basically just manipulating this data frame, and we're left with a DF. And don't mind the warning here. This was, I believe, in the original, and we're just going to ignore that. All right, so now we're ready to start Nextmvifying this model. And so this is where we're making, again, very minor enhancements or modifications to what Gurobipy has already done in their original notebook to hook this up to Nextmv. So to do this, we're creating a class which is called the ML regressor model class. You can call this whatever you want. The only important part here is that it inherits from the Nextmv model class from the Nextmv SDK. This class also has a solve method that we're defining on it. That solve method conforms to this signature of receiving a Nextmv input and writing a Nextmv output. The other piece to Nextmvifying is redirecting any chatter that's going to standard out to standard error, because the Nextmv convention for logging is to go to standard error. So anything that's redirected there gets surfaced in the Nextmv logs, and anything directed to standard out is considered the solution to the problem. And then the last change here or update here is that we are reading the data from external instead of defining that data within the model itself. So we wouldn't want the model and the data to be commingled together, because what we want is for this model to be standalone and be able to receive input data from the outside. And then everything else here is copy-pasted code from the original notebook to train and test the regression model. And the remaining Nextmvifying block is right here. And so what we're doing here is really just exposing our KPIs or our statistics for this regression application. And so in Gurobipy's original notebook, they were surfacing the R squared of the test set and then the R squared of the full unpartitioned set. So I just decided to go ahead and return those as custom statistics here. And lastly, we're just returning a Nextmv output. A Nextmv output has options, the solution, which is the fitted coefficients, and statistics. So that's really it. It's really just surfacing KPIs, formatting the output, formatting the input, and redirecting solver chatter. And everything else is just copy pasted in. So you might be wondering, why are we training and testing within the same application? And I did just want to call out that you don't have to do it this way. If you have an ML model and you're using MLOps to train and fit that model, you don't have to move away from that when you want to work with Nextmv. There is a home for both MLOps and DecisionOps in this space. What we did is we just wanted to take Gurobipy's original notebook and just run it on the Nextmv platform. So that's why we constructed the application this way. But again, you can load the ML model from the outside as well, and have it trained somewhere else. All right, so that's it for Nextmvifying that application. So now we want to run it locally before we deploy it to the platform. And so to do that, we would instantiate that class that we just created. We would define a Nextmv input, and that input is composed of data, which we're passing in this dict version of the DF that we prepared above, and just Nextmv options, which are empty in this case. And then we're using the solve function on that model class, passing it the Nextmv input, and we receive a Nextmv output. And then we're writing that output locally. And so you can see we have our solution to the problem, which is the fitted regression model to characterize the relationship between price and demand. So now that we've confirmed everything works locally, we're ready to deploy that to the platform. And to do that, we can create a Nextmv client. And this is why we needed to configure our API key in the notebook, because we're using that API key to hook this up to our Nextmv account. And once we do that, we just have to define the app that we want to push up to. So in this case, I've defined the avocado ML regressor application that I want to push to. And I've defined some model configuration, for example, the versions of the Python packages that I want to be bundled up with my executable. And then we create an app manifest based on that model configuration. And then we push up to that regressor app the local version of our model that we've created from this notebook, plus the app manifest to describe the dependencies it needs and the model configuration. And you can see that since we hit run before this was all running, we have successfully deployed to this endpoint our ML regressor model. So now let's have a look at our account, and we can see that we did push this up a few minutes ago. And that executable now exists in this application space. So you can see that when you have an application, you have basically an API and a UI that comes along with your decision model. So you have access to your run history. So I've obviously made several runs on this application prior to today. You have access to versions. So you can cut a version of that application and call this, version 1, or this could be a commit SHA, tied to your GitHub repository and have this hooked up to CI/CD. And so that's versions. You can have instances. So instances are really the endpoint that you're making your requests to. And an instance, typically we see, dev, staging, and prod instances, or maybe you want to partition by region and say this is your New York City instance. And so for an instance, you can specify which version of your executable to use to make a run on. And if that instance has any secrets that need to be set, like for example, if you have an API key to some external service that you're integrating with, you can set that here. And then if you have any configuration options, so for example, maybe New York City has a higher activation penalty than Houston, Texas. So you could set that in your configuration values here. We also have experiments. So you can run scenario tests or batch tests, which are sort of ad hoc kind of exploratory tests on historical data. We have acceptance tests, which are for hooking up to your CI/CD and saying, is this change acceptable based on my KPIs? And then we have shadow and switchback testing, which are some production traffic tests for deciding go, no go on releasing a new version to your production instance. All right, so that's what you get when you create and push up an executable to an application on the Nextmv platform. So now that the app is deployed, we can make a remote run on the platform. And remember, there are various ways to make a run. Here we're using the Python SDK to make a run and passing in that input, that DF that we prepared above. And we can see that we've successfully made a run on the platform. And if we go to our run history, we would see that run. And along with that run, you have metadata, you have statistics, you have any configuration, if there was configuration exposed by the executable. And you can always go to your input tab to get the input that was used to create that run, as well as the result to get the result of that particular execution. And in this case, the result was, again, the fitted coefficients of that regression model. And if you had any logs exposed, those would show up here. All right, so we've gotten through our first app of the fitted regression model running as a standalone application on the Nextmv platform. Now we're going to do all of that again with the avocado price decision model. So we're creating this avocado price decision model class, which inherits from the Nextmv model class. It still has that solve function on it, which reads in a Nextmv input and it returns a Nextmv output. It still reads the input data from the outside. We're doing one additional thing here, which is we're exposing an option from the outside called supply. And this is essentially making it possible for us to change the starting inventory or the starting supply of avocados without having to manipulate the input data itself. And so we'll see in a minute why this is useful on the platform for running experiments. But really, this just allows us to change that one option while keeping the input data constant and being able to understand how changing the inventory or the supply of avocados impacts our downstream KPIs. The other change that we're making here is we're using the Nextmv Gurobipy package to define our model. And we're doing this because it has some nice helper functions for working with Nextmv. So for example, it preloads all of the Gurobipy solver options for us, so we don't have to kind of enter those or expose those on our own. And it also has some helper functions for working with statistics. So that's really it in terms of this first part of Nextmovifying the optimization model. Everything else here is copy-pasted code from the original Gurobipy notebook, so I didn't have to make any changes here. The only change I will call out that I did make is I migrated the plot visualization of the results to Plotly. And I did that so that I could expose this as a custom visualization. Since Plotly can export images to JSON, then we can use that on the Nextmv platform to have a custom visualization for the solution to the optimization. I did not count this as Nextmovifying because it's really more like Plotlyfying. So then really the only other piece for Nextmovifying is exposing statistics and that custom visual asset. So here for statistics, we're using the Nextmv Gurobipy package to instantiate our model statistics. And then we're adding some custom statistics in here as well. So when we use this Nextmv Gurobipy package, it does some nice things. Like, for example, it pulls the objective value from the solution and sets that to the objective value of our statistics block. So we don't have to do that. And then all we're adding here are some helpful custom statistics like the number of variables created, the number of constraints. And then since we ultimately want to know how increasing starting supply impacts our downstream KPIs, we definitely want to make sure that we're surfacing the total waste, as that's likely to be impacted by increasing the starting supply. And so other than statistics, we're exposing in this model an asset. And this asset is creating a custom visualization. And so you can see the content here is really the JSONified Plotly visual. And because we're using this asset convention from the Nextmv SDK, and we're returning that asset in the Nextmv output, the console, the Nextmv console is going to pick up this custom visual, create a new tab for us, and render that. So we'll jump in to the Nextmv console, go to our apps, that price optimizer app, and we'll go to a run. And we can see here that when we made a run on this avocado price optimizer app, we have this new tab that pops up that says pricing charts, and it has that custom Plotly object that we just returned in our assets. So when we follow that convention, this is what we can do, and we can have many plots on this tab, or we can have many plots on many different tabs with this custom visualization feature. All right, so as part of the notebook, we also created our data dict. And what we did here is we manually defined this input data that Gurobipy was using in their notebook. And the one change here is we passed in the coefficients from the remote run of the regressor application. So we're kind of weaving those two inputs together. So now we're ready to run our model locally. And so what we can do is we can define the Gurobipy options using the Nextmv Gurobipy package. So this just preloads all of those solver options. Now we can define some additional Nextmv options. And so we said we wanted to expose supply as an option so that we could define different supply values from the outside. So that's what we're doing here. And then we're taking those Nextmv options and merging them with those Gurobipy solver options to get the full set of options that are available to us to pass in from the outside to this application. And now we're ready to run locally, and I've hidden the output here because it is very long, because we have that JSON Plotly object in the output as well. But really what we're doing is creating our input, instantiating our model, running model.solve on that input, and returning the output. And so we can see here the cloud version of that from running remotely. And so we take all of that JSON output and we present it in a tabular view so it's more human readable. So we can see this is the solution, this is the input with the various transport costs, product allocations, the minimum and maximum product allocations for each region. And we also have the coefficients from the regressor app that we're passing in as well. And so then when we click on result, we can see that this is the solution to our optimization problem. So for each region, we have an optimized price, optimized allocation amounts in millions of avocados, and then some other data about sales and waste and predicted demand. And then if we click into our logs, we can see that we have the parameter setting logs printed here, as well as the standard Gurobipy solver output that most people are very accustomed to viewing. All right. And so that's the result after we went ahead and pushed up our avocado price optimizer app. We configured it, created a manifest, and used the .push SDK command to push to that application. And again, this is where we ran remotely to produce this run that we just looked at. All right, so up to this point, we have two distinctly managed Nextmv applications, the ML regressor app and the price optimizer app. So now we're ready to create a third application, which is a workflow application that chains these executions together. So what we've done here is just taken that avocado data from Gurobipy, and we've dumped it to a CSV so that we can have that handy for loading that into the platform. Then we've installed Nextpipe. Nextpipe is our engine for building workflows on the Nextmv platform. And now we're ready to construct our workflow. So this is really what we want to be building. We want to be able to load CSV data and transform it to a pandas data frame. We want to be able to receive that pandas data frame and do all that preparation that Gurobipy was doing in their original notebook. We want to now call that deployed regression application. We want to then take the fitted coefficients from that application and join that to the optimization input data. Then we want to call the deployed optimization application to solve for the price and supply of avocados per region. And then we want to post-process those results to transform them into a Nextmv output that is easily human readable. So that's what we'll be doing here, is creating that workflow. So we can do this by creating a Python file structure. So what I'm going to demonstrate here is sort of an alternative way to define a model or a workflow, which is in files versus in the notebook. So that's why you're seeing this write file magic command at the top here, because I'm actually demonstrating it in a notebook, but ultimately what we're doing is creating the actual files themselves to push up. So that's why we're creating a workflow folder, and we're writing a main.py, which creates this workflow. So we're exposing some Nextmv options, like the input path to the input data and the supply or inventory of avocados to start from. And now we're using the Nextpipe flow spec class to create a workflow. And to do this, we're using the @step decorator on each of these functions to define steps in the workflow. So the first step is to load the data and convert it to a pandas data frame. The next step is to prepare the data, and prepare receives as a predecessor the results from load, so that pandas data frame. And then it runs all of this data preparation code that is copy pasted from Gurobipy. And it returns a dict of that data frame. And the next step is regress. And regress has a predecessor of prepare. And what regress is doing is actually just using the app decorator from Nextpipe to run that remote application using the results from its predecessor prepare. So really we're taking that data frame and we're just running it remotely on the Nextmv cloud. Then the next step is join. And so join is taking in the results of prepare and regress, and it's combining the optimization input file with the results of the regression solution. Then we have the optimize step, which receives the results of join, and it uses the app decorator to run the optimization in the Nextmv cloud. And it's additionally passing in whatever the supply parameter was that the user passes in on the workflow configuration. And then lastly, we're just post-processing those results to create a tabular view of the solution to the optimization. We're adding our statistics and our assets, and we're returning that output. And then our main function is simply just creating a client so that all of the child apps can be accessed by the parent workflow app. We're instantiating our workflow, we're running it, we're getting the result from the final step, and we're writing it to local. And then here, since we're using a file-based structure, we need to have a requirements.txt that gets bundled up with our application. And then lastly, we are creating our workflow app in the Nextmv cloud. And we're creating our app manifest that gets pushed to it. And then we're pushing our local files up to that workflow application from the workflow directory. And then here, I'm creating a secret on the Nextmv console and passing in my Nextmv API key. Now, I actually had already created this, so I'm getting an error, but we can just go ahead and ignore that since I forgot to delete this before doing this call. And so we can see here that our workflow was successfully pushed up to that workflow application. So now let's have a look at that. So if we go into apps and workflows, we can see we have a workflow application, which is blue instead of the custom yellow. If we click into that, we can see that we deployed this a little while ago. And what we can do is go ahead and make a run. And we can select our instance to just be the default. And for the configuration, we can set this to, let's say, a supply of 30 million avocados. And now in this case, we need to specify the workflow secrets that we created. So this is just my API key so that my workflow has access to all of the child applications that it wants to run. And so we can go ahead and start that run. And we'll see that fire off soon. And I can actually go to a run that has already completed. And what we're seeing here is that we have that same view that we've seen with some of our other applications that we've looked at, where we have the statistics, we have the metadata, we have our input, which can be downloaded in tabular form. We have our result. We have logs about the workflow and all of its status as it's going. We also surfaced that plotly visualization to the workflow, so we get that view as well here. And we have one additional view now called flow. So because this is the workflow, we can see this flow chart of the status of the workflow running at each step. So we can see that we're loading, preparing, regressing, joining, optimizing, and post-processing. So now let's go back to our original problem. So our original problem was, should we go with this new avocado supplier? So what we can do is we can jump into our optimization app and we can run a scenario test to answer that question. All right, so we can create a scenario test here to answer the question of how supply impacts our downstream KPIs. So what we can do is call this evaluate different supply values. And under our scenarios, we can either create an input set with that input to the optimization model, which I have previously done, or you could go to upload files and upload the input that this optimization model expects. Either works. Then under instances, we can select latest. And under configuration, this is where we can use that option that we exposed with the Python SDK. And let's explore 20, 30, and 45 million as our starting values for avocado inventory. So what this is doing is it's actually just firing off those 3 runs from this interface so that we can see what the downstream effect is of different supply values. And so that fired off, and now we can see that those runs are executing right now. So we get access to all those child runs along with their metadata and statistics when they complete down here. And when this scenario test completes, we'll be able to get a nice interactive pivot table to view those results. So while this is waiting, I also can show you a nice feature here called clone. So what we can do is click on clone scenario, and we can always get the sort of the original form that we filled in for creating a scenario test. So you don't have to pre-fill in all of this data if you just want to rerun it, an existing test. And we also have that available for creating new runs from past runs and new instances. So that's a nice little feature. All right. So that completed. We can see we had 3 successful runs, and now we have a view of our pivot table. And so what we can see here is we're viewing our objective value, which is profit. And we can see that when we go from 20 million to 30 million to 45 million, we have this nonlinear relationship between supply and profit. So we can see that we have an increase in profit when we get to 30 million, but then we decrease when we get to 45 million. Though that decrease is still more profitability than the 20 million supply. But it's something to be mindful of. So it seems like adding an avocado supplier is probably a good thing. We're seeing that the profitability is increasing, but we might want to understand, why is it not increasing linearly? Well, because profit is revenue minus costs, let's have a look at the total waste cost. So we can see here that when we had 20 million avocados, we had 0 waste. When we bumped it up to 30 million, then we had a little bit of waste. And then when we bumped up to 45 million, that's when we saw a big spike in the waste cost. So what does this tell us? It tells us that we can't just have a huge supply of avocados, because we're not going to be able to move that inventory, and we'll have some waste cost incurred. But generally, adding a new avocado supplier does seem like it has benefits to profitability, and that's probably something that we should think about doing, and maybe adding some more tuning and some more granularity to this configuration view, so that we can get a better idea of where our inflection point is. So that was our speed run. What did we just do? We created 3 apps: an ML model, an OR model, and a workflow. We ran and deployed everything from the notebook. We then ran a decision workflow and visualized those results using Plotly. And then we ran a scenario test to simulate the question of, should we increase our avocado supply by adding a new supplier into the mix? And then we communicated that relationship to our stakeholders. So now let's take a zoom out view here. So Nextmv is one home for all your optimization work. You can manage all of your different decision models with the different underlying technologies, all with that same common API layer. And having that common API layer and that standardization really can help improve your optimization work. So it minimizes having repeated imports and boilerplate code that you're copying and pasting from each optimization application to the next. It gives you a construct where your options, solutions, statistics, and assets can all have the same structure and be very familiar to different members of your team. The common integration pattern simplifies the workflow of a software engineer when they're integrating this into the upstream and downstream systems. And then having an API reference every single time you push is huge. You don't have to create your own API endpoints every time for every new application that you build. And as part of all this standardization, Modeler 2 can come into the mix and easily pick up where Modeler 1 left off. So it's just really convenient when everyone has the same common understanding of how we build optimization models. So what we want to do here is make optimization more readable for humans. And so there certainly is a time and a place for the raw solver output that comes out of an optimization model. The decision modelers really care about that and want to view that result. So we're not saying do away with solver output. What we're saying here is that we wouldn't necessarily want to present that solver output to a business stakeholder. They're not going to know what's going on. So what we're working towards at Nextmv is creating an experience for a a non-technical person or a less technical person to be able to understand and interact with this underlying technology that the decision modelers are exposing to them in a way that makes it clear what's going on. And so we're not going to get into this today, but we'll have a follow-on session where we talk a bit about what we're working towards on the collaboration and feedback side with things like annotating on runs so that the decision modeler and the analyst can kind of go back and forth and have discussions around what they're seeing. And so we'll follow up with another video on that. And this concludes the workshop on building out a workflow at Nextmv. Thank you for tuning in.